Okay, let's unpack this. When you picture plastics, what do you usually see? For many of us, I think it's that overwhelming image. 400 million tons produced every single year, suffocating our oceans, piling up in these enormous landfills. And then the truly insidious part, breaking down into microplastics that are now, well, undeniably everywhere in the air, in our food, inside animals, plants, and yes, even within us. It feels like the ultimate environmental villain of our modern age, right? A stark symbol of human impact. But what if I told you that these very plastics, the ones we so rightly see as a global crisis, are simultaneously something far more profound? What if they are actually a vital, undeniable archive documenting human history, maybe even a treasure trove for future generations?
What's truly fascinating here,
Yeah.
and really the core of this deep dive, is exactly that paradox. There's a groundbreaking new study led by Professor John Schofield and his team, a real mix of disciplines from the University of York, and it was published in Cambridge Prisms, Plastics. And it argues that modern plastics aren't just, toxic byproduct. Instead, they're forming an important archaeological record. Their whole mission was to explore how these pervasive plastics aren't just pollution. They're also a valuable archive that documents human impacts on planetary health. So we're going to explore this really profound contradiction, how we as a society grapple with something that is both a dangerous contaminant and at the same time a crucial historical documentation of our current era. It's a completely new way to look at our waste.
It's an astonishing reframe, isn't it? Before we dive into the details, let's maybe step back a bit and set the stage for how we even got here. We're all familiar with historical epochs like, the Stone Age, the Bronze Age, or the Iron Age. Well, this research introduces us to a new one, the Plastic Age. And what really makes this era stand out, especially archaeologically speaking, is its unique beginning. Unlike previous ages, which often popped up at different times in different places, the Plastic Age essentially kicked off simultaneously across the entire globe, right around the 1950s. This universal starting point, really driven by the explosion of single-use plastics, makes it a truly global phenomenon, a shared material culture. And it's deeply intrinsically linked to other huge issues of our time that the researchers point out, things like relentless consumerism, widespread habitat destruction, and of course the massive combustion of fossil fuels. It's all incredibly intertwined.
Yeah, and if we connect this to the bigger picture, this is where archaeology's evolving role becomes absolutely critical. Historically, archaeology focused on the distant past, unearthing ancient stone tools, metal artifacts, ceramic shards, that sort of thing. But in recent decades, the discipline has really broadened its scope significantly. It now includes contemporary societies and the material culture they leave behind. I mean, think about it. Our mass-produced, often single-use items are just as much artifacts as an ancient font, in a way. This new, more expansive, more interdisciplinary approach positions archaeology perfectly to study plastic pollution. It transforms it from just an environmental problem into a rich, complex data source. It allows us to construct a detailed record of our present-day behaviors, what the researchers actually call an archaeology of us. The study even suggests we should start viewing our entire environment as a kind of living archaeological archive, one whose story can be studied not just to understand plastic pollution, but, crucially, to help us reduce it. It's about recognizing our trash as this ongoing global narrative of our times.
That idea of an archaeology of us, it really does make you think about your recycling bin and honestly every piece of plastic you touch in a completely new light. What I find particularly interesting is how the study traces the journey of plastics, from our everyday life into this unexpected archaeological record. It actually builds on a concept from way back in the 1960s and 70s by an archaeologist named Michael Schiffer. It's called behavioral archaeology. And this describes how artifacts move from their systemic context, that's when they're in active, purposeful use, to their archaeological context, which is, well, when they're ultimately discarded or lost. And along this journey, artifacts don't just sit still, they undergo what Schiffer called transforms. So you have C transforms or cultural transforms. These are actions driven by humans. Imagine like agricultural plowing, disturbing buried tools, or the deliberate act of filling landfills. It could even be waste management practices on fishing boats, whether trash is intentionally or accidentally thrown overboard. Then there are N transforms, natural transforms caused by environmental forces. Think about powerful water currents carrying debris, or the relentless breakdown from UV light from the sun, extreme heat, strong winds, the abrasive action of waves. And plastics, just like those ancient stone tools or ceramic shards, are constantly subjected to these transformations. They don't simply vanish, they continually break down, often to nanoscale particles. And these processes are all critical parts of their unfolding story, just waiting to be read.
Exactly. And to truly understand those transforms and the story they tell, we need to get a bit specific about what plastics actually are and where they end up. While there are many types, mass production is largely dominated by just a few key kinds. You're probably familiar with polypropylene, common in food containers, or polyethylene terephthalate, PET, that's used in most water bottles. The crucial point isn't really remembering all the chemical names, but understanding that these specific types, along with others like polystyrene or polyvinyl chloride, have unique chemical structures. And those structures dictate how they behave and how they break down. Then there's the question of size, which significantly influences their journey and their impact. We categorize them. Macroplastics, anything larger than 25 millimeters, think full bottles or bags. Mesoplastics are between 5 and 25 millimeters. Microplastics, the ones we hear so much about, range from 5 millimeters down to 1 micrometer. That's tiny. And then the smallest, nanoplastics, are less than 1 micrometer, incredibly small. It's also really important to distinguish between primary microplastics, the ones manufactured to be small, like microbeads in cosmetics or fibers from synthetic clothing, and secondary microplastics, which result from the degradation of larger items, those bottles or fishing nets breaking down over time. The size truly dictates their potential impact. From macroplastics causing entanglement in wildlife to microplastics accumulating in organs, and critically, nanoplastics being so tiny they can cross our cell membranes, even the blood-brain barrier.
So the smaller the plastic, the more insidious its journey into the record and, potentially, into us. Given this incredible range in size and type, what are the diverse pathways plastics take into this archaeological record, especially since the 1950s?
Oh, their pathways are incredibly diverse. It really reflects how pervasive they are. On land, in our terrestrial environments, plastics are just everywhere. This includes deliberately buried infrastructure like pipes and cables, general litter that accumulates, and even agricultural soil treatments where plastic mulches degrade right into the ground. And most significantly, landfills receive a staggering 85% of all discarded plastics. They create these massive artificial geological layers. In aquatic environments, nearly 8 million tons of plastic make their way into marine systems every year. They form these vast accumulations like the infamous Great Pacific Garbage Patch, which is essentially a huge, floating, active archaeological site of our consumption habits. But it's not just our populated areas or the oceans, not at all. Even in the most remote regions like the cryosphere, think Antarctica, scientific station equipment, the synthetic clothing worn by researchers, even the flags used for wayfinding, all shed microplastics that deposit onto snow and ice. And then there's outer space, which is just wild. Plastics are fundamental components of spacecraft, used for insulation and protective blankets. We have a significant amount of debris in Earth's orbit, an estimated 36,000 pieces larger than 10 centimeters. That's collectively around 9,000 tons of space junk. And, astonishingly, plastics are even on the moon. Things like the Apollo flags, the captain blankets from the lunar landing vehicles, the archaeological record of plastics is quite literally extraterrestrial.
That's a truly mind-boggling thought. Plastics forming an archaeological record on the moon. Wow. But to brought even closer to home, or perhaps more accurately inside us, what if this archaeological record isn't just around us or on distant celestial bodies, but actually within us? The research clearly states that micro and nanoplastics are routinely found in human and non-human biota, that's plants and animals, and even in bodily waste. This means that, and I'm quoting here, components of all biota now contain a plastic decay product, unquote. It's an archaeological record living inside bodies, with what the researchers call archaeological depth. It depends on how far these particles have penetrated our different tissues and cells. Imagine it like, layers of sediment or tree rings. But instead of marking geological time or years, these microscopic plastic layers within us chart the physical impact of our modern material culture on life itself. The deeper the penetration, the more profound the archaeological depth of our plastic footprint. It's a profound and, frankly, pretty unsettling idea.
It really is. And this phenomenon of biological infiltration raises a tremendously important question. What does it signify about our relationship with the natural world? It leads us to Vladimir Vernadsky's concept of the noosphere. He envisioned this as an evolutionary stage where human cognition and technology would ideally align harmoniously with natural systems, like a sphere of human thought interacting with the biosphere. But the pervasive presence of plastics, especially within living organisms and across the entire planet, fundamentally challenges this ideal. The study argues that plastics don't just represent a new state of the biosphere, but they reveal the darker side of human ingenuity. They reflect a profound failure, really, to fully grasp the long-term consequences of our innovations, and thereby they're stalling the attainment of the noosphere. So in essence, if the noosphere is humanity's ideal harmony with nature, plastics aren't just a byproduct, they're literal evidence embedded within us and the planet, acting as a permanent historical marker of failure to achieve that harmony. And these plastics aren't just inert passengers either, not within us or the environment. The documented health implications for biota, including humans, are genuinely concerning. We're talking about things like physical damage, chronic toxicity, cell damage, inflammation, oxidative stress. And the risk significantly increases with smaller particles, especially those less than 1 micrometer, because they can cross critical biological barriers, like cell membranes and potentially even the blood-brain barrier. Their presence in human feces is also clearly documented, which indicates a pathway right through our digestive systems. It's a clear, indisputable signal that our ingenuity has created a material that now intimately shapes our biology, for better or, likely, for worse.
It's truly astonishing how far plastics have traveled and how deeply they've become integrated. But if they're everywhere, from our bodies to the moon, how long do they actually stick around? The popular image is often forever, right? That a plastic bottle will last eternally. But is that the full story? The science seems to offer a more nuanced picture. It makes it incredibly difficult to predict exact degradation times. Even with accelerated weathering experiments, scientists can only estimate that plastics can degrade anywhere from, well, decades to more than 1,000 years. It's not a simple single answer. It's a complex range depending on many factors.
Exactly. That wide range in degradation time is influenced by several critical variables. Things like the specific type of plastic, the intensity of exposure to UV light, ambient temperature, oxygen levels, the presence of water, and even microorganisms play a role. And as plastics degrade, they aren't just disappearing, they're actually interacting with natural materials, and in some cases, forming entirely new geological formations, which is fascinating. The research introduces us to concepts like plastiglomerates, which include pyroplastics, plastic crusts, and plastitars. These are being found in places like the Canary Islands and the Mediterranean. It's where plastics have melted and literally fused with natural solid particles like gravel, sand, silt, and clay. They're creating new, human-made plastic rocks. Imagine future archaeologists unearthing these strange new formations. What stories will these unexpected geological fusions tell about our habits and consumption? Quite something.
That's a powerful thought. Our waste literally becoming part of the Earth's geology, creating these plastic rocks. How do these degradation processes vary in different environments? Especially in those extreme places we mentioned earlier, like space.
Yeah, the degradation processes indeed vary significantly by environment. In aquatic systems, for example, microorganisms form what are called plastospheres, these novel ecological habitats that colonize plastic surfaces. Some bacteria and fungi have even been found to degrade certain polymers like biodegradable polylactic acid or PLA, even in the deep sea, though generally less efficiently than in coastal areas. In open space, however, the degradation is dramatically faster, much faster. The extreme conditions up there, atomic oxygen, ionizing radiation, vacuum UV, are highly damaging. The nylon flags planted on the moon, for instance, they're expected to have broken down substantially under that intense unfiltered UV radiation. And the plastics on Elon Musk's Tesla, the one famously launched into solar orbit, completely unshielded from cosmic radiation. Those are almost certainly heavily degraded by now. So while some plastics might persist for centuries or millennia here on Earth, our spacefaring plastics have a very different, much more rapid decay story.
It truly brings us full circle, doesn't it? Plastics aren't just pollution. They are an undeniable, pervasive, and incredibly enduring record of our time. A literal archaeology of us. They tell a story of our behaviors, our ingenuity, and our profound impacts on the planet, extending from the deepest oceans to the furthest reaches of the solar system, and yes, even within our own bodies. So what does this all mean for us right now? It means we're facing a critical choice, really, as a society, about how we interpret and act upon this unprecedented legacy.
Precisely. And the researchers themselves pose a vital ethical question here. Plastics unequivocally represent a major environmental challenge, right? Threatening planetary health on a grand scale, we know that. But simultaneously, they form an invaluable archive, documenting human behaviors at what is undeniably a critical stage in human history, the Anthropocene. With traditional archaeological remains, our immediate impulse is usually to preserve them, to study them meticulously, to understand past human agency. So, should we therefore approach this emerging plastic archive with a similar, perhaps more nuanced perspective? Acknowledging its tremendous harm, yes, absolutely, but also ensuring this unique, pervasive record is carefully understood and analyzed for the insights it offers. What will our plastic legacy vividly tell future generations about us? And perhaps more importantly, how can this understanding better guide our actions now, pushing us towards a future where human ingenuity genuinely aligns with planetary health rather than working against it, finally achieving that noosphere? It's a question that demands deep reflection and probably some immediate decisive action.